Welcome to this new season of videos on application modernization. In this second season, we'll focus on artificial intelligence, particularly related to Agentic. For this first episode, we'll show you how to create a digital twin from an application by using various data sources. Thanks to this digital twin, we can recreate an application in low code directly using the AI module of the OutSystems solution. To get started, we'll revisit the MedRec application used in Season 1. MedRec is a 20-year-old application that could only be modernized to a cloud-ready state by splitting it into 3 macroservices: chat functionality, patient management, research/registration workflows. Further cloud-native modernization, e.g., microservices, serverless architecture, is currently unfeasible due to technical limitations. To address this, we'll create a digital twin of the application. This twin will reformulate functional/technical specifications, redesign security protocols, rebuild integration workflows. The finalized digital blueprint will be fed into OutSystems AI module, Mentor, which will automatically regenerate the application using low-code/no-code principles. A recent McKinsey report highlighted the use of artificial intelligence, both generative and agent-based, in terms of modernization. So we see that there are 2 important elements or factors. The first is the impact on the functional effort, which means rediscovering needs, and if necessary, redefining business processes. Looking at use cases. So this is the part that is in light blue above, where we can achieve up to 70% gains in this area. And then the second element is the technical effort, which includes development, testing, and deployment, which are obviously extremely low with a low-code platform. So the first thing we can see is that by using only generative AI, we can achieve up to a 20% reduction in implementation time, whereas if we go up to the agent-based part, we can achieve up to 50%, knowing that overall, the modernization effort goes from 100 to 30, but 70% reduction. This means that modernizations that were not possible in the past will now be possible, particularly in terms of much lower costs and timelines than what would have been required if the application had to be redeveloped from scratch. So, the way we do it at Airways Engineering is divided into 2 parts. The first is the analysis of the entire documentary corpus that may exist, including source code, knowledge bases, and multimedia support such as video or audio. From there, an initial agent team will be responsible for analyzing the entire corpus and effectively recreating a comprehensive understanding of the application. Within this team, there are 5 main agents, one with the role of business analyst for the functional business part, one with the role of software architect for the more application-oriented part, and one with the role of senior developer for the code part. Above that, we have 2 additional agents. The first is the tech lead who will orchestrate the 3 previously mentioned. And then the last is the product owner, who will serve as a focal point afterward, knowing that a request can be routed either to the tech lead if it is not known by the digital twin or directly to the digital twin. The second step is the creation of this digital twin, which will be a digital incarnation of the application and will have complete knowledge of its entire corpus. From there, it will be capable of, by working in interaction with human teams, recreating detailed specifications and thus a well-defined target state. From there, once the detailed specifications have been completed, we pass everything to the OutSystems platform and its Elementor Studio system, which allows for the development of an initial iteration of the application based on the specifications, which is what we will demonstrate in the following demonstration. Lastly, the digital twin does not stop at the creation of the first application, but will continue to exist to provide insights on maintenance, technical debt, and potential issues that may arise. So we return to our MedRec application and log in as an administrator to check if there are any patients waiting for registration. Here we see one named Charles, so we'll review his record and approve it. That's the first case, and we'll compare it later with the part on the system. The second case concerns the patient, where they log in and check their appointments and prescriptions. So that's a second character and a second use case. We log in as Fred, and then we look at the summaries in terms of records. I see the records in terms of visits, the prescriptions I received during the visit, I see the details, so the prescription as well, I see what was prescribed to me. As Fred, I can view my profile and change it if necessary. These are very simple use cases that allow the patient to see the visit they made, etc. The last element is for the practitioner who can propose prescriptions to different patients. So here I log in as Mary, the practitioner, and look for Fred Winter, whom I just saw via his social security number. I check the prescriptions. I see what has been assigned to him, and then I can add records during a medical visit to see how he has been. This is a very simple use, and we'll see how we do it on the other side. So here we switch to the digital twin, which actually has multiple personas. Here we see the application owner or business analyst, so I ask them, what are the perceived functional data of the application? What are the personas? We see a complete summary made from the knowledge base and documents provided by the various teams. Next, I can switch personas and take on the role of the architect. I ask them to present an overview of the MedRec architecture, which goes into a bit more detail. We will have the different functional components available, as well as graphical views. In this case, graphs represent the different domains. We see there is a MedRec domain, a server part, and a database part, providing important elements about the application structure itself. For the third agent, we'll look at the developer. We can simply ask them to give us the content of an EJB for the practitioner, and they will directly search the source code for the EJB code for the practitioner. These are three very simple agents that are then directly orchestrated by a tech lead who ensures the right questions are asked to the right people. For example, what should I do to make it cloud native? We will first use cloud native services and functions available on public clouds. Then, when I ask for a microservices architecture, they break it down with microservices for patients, practitioners, and the prescription part, and then we see the mapping done with the business workflow. This is in the case where I take on the role of the product owner and ask about the existing data flows. We see the data flows between the different components. And the last element is the digital twin itself, which has complete knowledge of the application. For example, I can ask for the data model, which will give me an initial element with prescriptions and related information. I can get elements on the business part, the functional part, and the use cases. It will be the primary interface for recreating the requirements. So from there, once the digital twin is in place, we can completely recreate the application specifications. We have a number of topics, about 10 are covered, so we see the functional part here. We can have elements on the part we'll see later, on integration, and on data management. There is a whole set of elements created from the digital twin. We also see the possibility of recreating elements, diagrams that present the sequencing of the integration. Here we see the APIs, so all of this does not exist as a document. It has been entirely recreated from the digital twin. So once we inject this document into Mentor on the OutSystems side, it regenerates a first application. This was all generated in less than 5 minutes from Mentor in your system, and we find the 3 personas. When I log in as an administrator, I see the patients I'm looking for, those who are pending. I can take one and activate it. This is what we had earlier in the original mentoring. All of this was done automatically. No code was produced. It was really Mentor that did it, so this is the administrator persona. The second persona is the patient, where when I log in as a patient administrator, I can see on a given patient, for example, Melissa, what her prescriptions are and what appointment she had. We find the same elements as we saw earlier. Note that in the case of another system, not only does it create the application, but it also provides different test data sets. And the last element, we also have the prescription part as we had earlier, so we have exactly the same paths as before, knowing that this time we have a much more modern interface with a low-code application hosted directly on a platform in our system. And the last element is the practitioner part, where I will be able to manage prescriptions. So if I take my name, for example, I see Frank, the date of birth, phone number, and prescriptions. I can add a prescription, for example, for Doliprane 500 milligrams, and from there, this prescription will be recorded and will be directly available on my profile. So we find it here, the prescription of what we just did. The application is not finished since, for example, there is no chat part included. There are access rights issues since, in fact, everyone has access to everything. However, it has completed 80% of the work. This is where we have a significant difference compared to what can exist in a much more traditional approach, as everything is managed by the digital twin. And from there, we are able to recreate, in low-code/no code, in a few minutes, a prototype application that can serve as a working base with business teams. Thank you.